Hello everyone. In this lesson we will be learning about how to write equations for circles. And if you have not already done so, you should have looked at the lab that is in the Chapter 10 folder on Blackboard. So let's kind of take a look at that together first. So in Blackboard you should go to Chapter 10 in Circles and then scroll down to the Labs folder. And in here I had some instructions for you to complete this circle lab. So at this time, if you've not taken the time to work through this on your own, you should stop the video, go back, work through the lab, and then come back and watch the video. Okay, if you have already worked through, we're just going to kind of take a quick peek at what you did. So here was our first worksheet. And what we were looking at is they had given us the standard form for the equation of a circle, which was located up here. And we were supposed to be looking to see what exactly do all of these variables do in our equation. So specifically, we were looking at what the h, the k, and the r had to do with the equation of the circle compared to the graph. Okay, so here we're looking at we have two circles. We have what they call the unit circle, which just means you have a circle centered at the origin with a radius of 1. And then our new circle is the one that is in red. And you were able to change the new circle by using these sliders up here. Okay, so for example, if we changed our r, which was just our radius, you can see on your lab, you should have noticed that as you increase the r, your radius would change. And here our radius, our slider says it's equal to 4. Our graph says the radius is equal to 4. Our equation says right here 16. Now if you go back and you look at the equation, it said r squared. So 4 squared is 16. Okay, let's take that back down. Let's go to make that 2. Okay, so then we wanted to know what does the h and the k do in our standard form. So here was our h. H was inside of parentheses with the x, and the k was inside of parentheses with the y. Okay, so first if we look at the value for h, here we have h is equal to 1, 2. Looks like our circle is being shifted to the right. Okay, so we'll put that back at 0. And our k, which is the variable that was inside with the y, as we increase that, our circle is being shifted up, and then if it's negative, it's being shifted down. Okay, our h, same thing. If you shift that to negative values, that's being shifted left. Okay, so we kind of see some transformations taking place here. Let me change this k. Let's make that 2. Okay, so here we have h is negative 1. Inside of our equation, we see a plus 1 because up here it was a minus h. So minus a negative 1 gives you the plus 1. And then here k was 2. So here we have a y minus 2. Now, whatever the value of h and k are, notice that is exactly where your center point is, right? Because we took our original circle in blue, we shifted h, shifted it to the left 1 unit. Okay, so that took us to right here. And then the k shifted up 2 units, okay, taking our new center point at negative 1, positive 2. Okay, so h is negative 1, k is positive 2. Our circle center is negative 1, positive 2. In the equation, you can figure that out by just taking the opposite sign values of these. Okay, so that was the gist of that portion of the lab. Okay, so if we go back and we look at worksheet 2, this one was similar, just kind of a different idea. You were able to input your own equations. Okay, so here we have a circle. They gave us the equation was x squared plus y squared equals 25. So now that tells me that I have a center point at 0, 0, because there's no h or k. And my radius is the square root of 25, which makes that 5. Okay, and on this one you were able to change this equation. So if we wanted to change this to, say, 36, I should see my radius is now 6. And if I wanted to change my center point, let's see, if I wanted to change my center point, I had to change my equation up here. So let's say I wanted to make my equation so that my circle was now centered at 4. So it would be a minus 4. And I want it to be shifted down 1 unit. So I would make that a plus 1. Okay, so here my center now is at 4 with a minus 1. So remember, wherever your center is, the signs are opposite when you're looking at your equation. So here's your equation. So our center for x coordinate was positive 4, so that's an x minus 4. And our y coordinate was a negative 1. So back to the equation, we have y plus 1. And that was the gist there. You're just supposed to try out some different combinations and basically draw the same conclusions that you did from the first portion of the lab. Okay, so now let's take a look at our notes. So here on your notes, you're on section 10.7 in your notes. And you understand now where the equation of the circle comes from, the center, the radius, but you're going to need to be able to explain why. Okay, so if we think about what a circle really is, a circle is just a collection of all of these points that lie on the circle that are going to be the same distance from some common center point. Okay, these are all equidistant. Okay, which means we can represent them by the same value. In this case, the same value for a circle is just that you're representing it by the radius. So I'm going to sketch in, that's my radius. Okay, no matter what point you choose on the circle, the radius is always going to be equal to, we'll call it generic r here in this case. Okay, so the way that we can represent that is the radius is just a distance. So really, you're just calculating a distance from a center point to any point on the circle. Okay, so let's say, I'm just going to keep this very generic, so all in terms of x's and y's. Oops, I don't want to do that. We already have an axis, so here's our axis. Here we have the point 0, 0. Okay, now, since we're keeping this generic, I'm going to label my center as HK, right, to kind of go with our lab. So HK is my center. Okay, this point G is just some point on my circle. So I'm going to label that as x1, comma y1. Okay, and this can be just any point. And the idea is that the length of r represents the distance of all points on the circle from our center point, which is at HK. Okay, so this is key because this is how we come up with our equation for the circle. Okay, so since we want to represent that as a distance, we can just use our distance formula. Okay, so the distance or the length of the radius, we can just write that using the distance formula. Okay, well, distance formula, that is just going to be r squared. So our distance squared, or our radius squared, is equal to the change in our x-coordinates. So the change in our x-coordinates is you're starting out here at G, you're measuring to the center point. So we have x1 minus h, quantity squared, plus, now we need to do the same thing with our y's. So y1 and k, we need that difference squared. Okay, sort of like Pythagorean, same thing as distance formula that we've been doing all year long. And now you look, this is exactly the equation of our circle. You don't have to take the square root of both sides to solve for the radius. This is our standard form. So this is the standard form for a circle. And this will have with a radius equal to r, and center at hk. Okay, so that is where that equation comes from. Now the other way that you can kind of visualize this is if you go back to your circle and you drop down this right triangle. Remember, you're just doing Pythagorean. So here, this bottom leg, this is the same thing as the change in your x-coordinates. So that is just the same as x minus h. And then your other leg, that's just the same thing as y minus k. Okay, then if you just think of it in terms of Pythagorean theorem, you have if you just think of it in terms of Pythagorean theorem, you have a leg squared plus another leg squared equals your radius squared. Okay, which is exactly what we have here in our standard equation for the circle. Okay, so that's it for this video. You'll come to class ready to work on some practice problems, and we'll look at some other variations of things that you might have to do, whether it be graphing or coming up with the equation of the circle. Maybe they give you some different types of information. So we'll look at those examples tomorrow in class, and we'll see you then.